Good morning, Algebra 1, Period 1, 6, and 7. It's Monday, time to rise and shine and enter the land of conic sections, in particular the parabola. Yes, it's Monday. It's the 20th of April. It's time to get mathin'. So here we go. All right, Mr. Mays here. Today I would like to put up another example of a quadratic. I want to graph this parabola. And we'll see if we can't identify the components that I'm asking for and how we get the components that I'm asking for. So here goes. All right, Algebra 1. So today, a reading from the book of Conics, chapter 4, parabolas. And we're going to look at paragraph to graph a parabola. All right, to graph a parabola, we need at least 5 points. It's helpful to find those 5 points if we first identify the axis of symmetry. Now, the axis of symmetry, it's abbreviated AOS. It's sometimes called the line of symmetry. But anyway, the axis of symmetry, that's the first thing we're going to find. Now, the next thing that you have to have, you've got to have a vertex, okay? The vertex, it's the highest point if the parabola opens down. It's the lowest point if the parabola opens up. So we start talking about the range of this function. The y component of that vertex is going to be crucial in figuring that out. And that vertex is going to be a maximum, opens down, or a minimum if it opens up. All right? So either case, the vertex is on the axis of symmetry. I'll say it again. The vertex is on the axis of symmetry. All right? So once you find the axis of symmetry, it's going to be an x is equal to something. That something, that x value, is the x value of your vertex. Okay, that's the x value of the vertex. Well, I just need the y value of the vertex. So to find the y value of the vertex, you simply plug that x value in to your equation, and it gives you the y. And I will go through that with you. I will go through that. All right. Then we need a y-axis intercept. A parabola will always intercept on the y-axis. Okay, that's if we actually have a function. Okay, and I have to be careful how I say it, because some of you go, what happens if you lay it sideways? Well, you're right. However, if it's a function, they will have one y-axis intercept. If it looks like that, y is equal to ax squared plus bx plus c, it is a function, and that y-axis intercept, remember, every x value on the y-axis is 0. So put a 0 in there. Figure out what you got left, okay? And then you need some x-axis intercepts. Okay, now you can have 2 x-axis intercepts. And remember, every y value on the x-axis is 0. So start off with that. Chuck some zeros in there. Or you may have 1 y-axis intercept if the vertex actually sits on the x-axis. Or you may have none. If the vertex is above the x-axis and it opens up, it will never touch the x-axis. If the vertex is below the x-axis, opens down, there will be no x-axis intercept. All right, so let's have a look at what this actually looks like if you were to draw a picture, okay? So here's my beautiful parabola. Notice my axis of symmetry. It's that vertical dotted line running up and down. Notice that the vertex is on the axis of symmetry. The x-axis intercept is where it crosses the x-axis, and the y-axis intercept is where it crosses the y-axis. Notice it's symmetric. Notice that for every point to the left that has a y value has a point on the right with the same y value, okay? So I started with this equation here. F of x is equal to x squared minus 8x plus 12. It obviously opens up because the coefficient in front of the squared term, which is a 1 in this case, is positive. B is a negative 8, and C is 12, okay? Now, this formula for the axis of symmetry, some of you are stating, hey, I can't find the axis of symmetry and I can't find a vertex. Well, it's because you're not using that formula. The formula for the axis of symmetry is x is equal to negative b over 2a. Remember, x is equal to some constants as a vertical line, just like that, and the vertex is on the axis of symmetry. So, for example, the equation of this axis of symmetry is x is equal to 4. Notice that the 4, that is the x value of the vertex. If you put a 4 into that equation, you will get the y component of the vertex. All right? So this is what it looks like. Those are the pieces I want. I want an axis of symmetry, I want a vertex, I want x-axis intercepts, and I want a y-axis intercept. Now let's look at the mechanics of how we actually got that. So here's the stuff that I need. And this is how I got it. All right, so there's my function. I'm going to begin by identifying my A, B, and my C. Note, if you put a 0 in for x, if you make x is 0, all you got left is a 12, so that is the y-axis intercept. Done. Okay? All right, axis of symmetry. The equation, negative b over 2a, negative b over 2a, or in our case, x is equal to the opposite of a negative 8 because b is negative 8. A is 1. 2 times 1 is 2. Opposite, opposite, positive. 8 divided by 2 is 4. So the axis of symmetry is x is equal to 4. Take that 4, and load it to find the y component of the vertex. Take your axis of symmetry value. In our case, it's 4. And plug it into what you now have as y is equal to x squared minus 8x plus 12. Remember, f of x and y, interchangeable. And if you plug that in, you will get a negative 4. Okay? That's what you're going to get. Now, so now you know where the vertex is. Okay? That's your vertex. So now you have an axis of symmetry and a vertex, and you have a y-axis intercept. Now, to find the x-axis intercepts, what we're going to do, we're going to set it equal to 0 and factor it. Okay? Factor and solve, factor and solve. That's that chapter 7 stuff. Okay? So there it is. I need factors. The coefficient in front of the square term is a 1. So I need factors of 12 that add to a negative 8. Well, I know that 6 times 2 is 12, and if I make them both negative, negative 6 times 2 is positive 12, and negative 6 minus 2 is, in fact, negative 8. So I factored into that 0 is equal to x minus 6 quantity, x minus 2 quantity. I take each one of those little components, and I set it equal to 0. So x minus 6 is equal to 0, x is equal to 6, adding 6 to both sides. The second, x minus 2 is equal to 0, add 2 to both sides, and x is equal to 2. So those are my 2 x-axis intercepts. So what do I got? Do I have 5 points? I do. I have a vertex, I have a y-axis intercept, I have 2 x-axis intercepts, and I have symmetry. With symmetry, I can find everything that I need. For example, that y-axis intercept, if I know that I'm 4 units to the left of the axis of symmetry, at the same y value, go 4 units to the right. Okay? Now, this may not be on your graph paper. Fear not, young Jedis. You can pick any value for x that you want. Okay? Preferably something close to the axis of symmetry. If you were to choose x is equal to 5 and plug that in there, you could find a y component. That would give you another point. Use your rules of symmetry, you'll find the other side of that, okay? So when you get to the point where you find your vertex, you found your axis of symmetry, you found your x-axis intercepts, and you need additional points, just plug stuff in, okay? All right. So that was another example of how to graph a parabola, how to find an x-axis intercepts, y-axis intercept, axis symmetry, and a vertex. All right? So you get to practice that up some more, and I'll put up another one where we talk about a parabola opens down, and then perhaps something that doesn't have any x-axis intercepts at all. All right, maze out.